University of Amsterdam. His research focused on how values like human rights get inscribed in the internet infrastructure through its transnational governance. So please welcome Niels.
So I talk about internet infrastructure, and I think it's important because almost all processes in our society are now mediated by networking technology. So in our discussions, we talk a lot about the things that we see, namely the platforms and their governance. But the infrastructures that lie underneath that actually enable what is possible and what is impossible, and are often also the subject of where filtering information is taking place. So the most effective control is, of course, the control that one does not see. And therefore, I think it's important that we have a look at the internet infrastructure, which is an infrastructure of control that gets shaped in a fierce battle over who gets to control over it. And I will try to tell the story of the network by looking at 3 technologies and 3 institutions. I'll talk about protocols in the Internet Engineering Task Force, protocols, routing in the Regional Internet Registry for the large European region, RIPE, and how the next generation of networking technology, 5G, is being developed in the 3GPP, and all the values that are inscribed into it. When nearly all processes in modern society are mediated by the internet, this invisible architecture is setting the invisible rules. So Lawrence Lessig called this code is law, but law is also still law, so maybe it is actually something else. The internet is an affordance structure that not determines our behavior, but creates possibilities and impossibilities and shapes it and inhibits certain behaviors. I seek to understand the relations and ecology in which the internet architecture is produced. So we should not be fooled by only looking at technology if we want to understand technology, because technology is, of course, an inherently human activity. And so looking only at content is also like this, might be distracting the careful watchdog of the mind. So we look at institutions. I'll look at institutions, at the material technology, but also at the economy and identities that shape it. And I'm very happy to do that at a polytechnical university, where many of you will also understand what all goes into the development of technology. So sadly or weirdly, internet governance, the governance of this transnational network, is done quite relatively little. And it is very researchable. It's much more researchable than, for instance, the United Nations. It's almost like internet governance is hiding in plain sight with its open institutions, with all its documented deliberations and publicly available video streamings of all the meetings. Thousands and thousands of hours of video. So what I try to do is do a combination of quantitative and qualitative analysis. So I observed 5 years in these governance bodies, but I also tried to do quantitative analysis on mailing lists and all these standards and try to foreground all the discussions and tensions that are there about economics and politics. So when I got into doing that, I thought I will really need to dig deep. But weirdly enough, politics and values have been discussed since the inception of the internet. Sandra Brahman, who has been reading the first 1,000 internet standards, she is not an engineer whatsoever, so she often described that process as reading Martian upside down. But because she looked through, or actually did not read the technical stuff, she was very sensitive for the political and social bits. But all the technical bits, all the social and political bits that have been described, have actually often not been implemented. So many of the values that are being professed might actually serve as a legitimating factor and not as an inscription or an ordering mechanism. And this picture was taken at the Internet Engineering Task Force at their meeting in Toronto, just after the lights went out. And the meeting simply continued as if nothing happened. But what was really funny was that this was also the meeting at which they just decided that their meeting could not go to India because the infrastructure would be too bad. So there are a lot of contingencies in the network. But when we're talking and writing about the internet, one always has an important choice: to write it with a capital I or not write it with a capital I. So many engineers argue that one should and keep on using the capital I when referring to the current internet, because there are many other cases of internetworking possible. And when we look at the history of the internet, we often think of it as a linear development, but with exponential growth. But actually there have been many different networks with many different topologies, rationalities, and interconnections. And actually some were interconnected and some were not. So right now we think of the internet protocol, IP, as the main thing that's defining the internet. But there were many other stacks that were able to run. And actually, some of these networks were interconnected. So the routers in those networks did an active kind of translation. And this was very complicated because these different networks were not necessarily fully documented. And parts could be translated and some not. So there was a continuous negotiation between the networks on how and if they wanted to collaborate. And this was by no means a open field. This is a sample of a configuration file that translated between different email systems and that had really different understandings of what a message could look like, should look like, and actually whether you would be able to send it anonymously and how it would check your identity. So how to control so many different interconnected heterogeneous networks? This was the question that the International Standards Organization asked itself, and the International Telecommunications Union by the end of the 80s and the beginning of the 90s. And for the ITU, which is the oldest UN body, which precedes the United Nations by far, this was a logical thing, because it was set up as the International Telegraph Union and has always governed international communication networks. It did so for the telephone, and now it was planning to do so for the internet as well. And for that, they developed the OSI model, the Open System Interconnections model, which is still being taught up to today. And when it was brought up, it was a really interesting time, because it was the time when the US government was discontinuing the ARPANET, the NSFNet, and the electricity net, which were then the largest networks at the time. And the NSFNet was the main network. And why were they discontinuing it? Because they did not want to keep on funding with research funding a network that was exponentially growing and used for many different activities. Plus, funding from the education department limited the use of the network because commercial traffic was forbidden. So up to the early 90s, there was no commercial traffic on the internet. And that's something that's often forgotten in many internet histories. So the way that, that the US government thought was the best way to scale the internet was, beginning of the 90s, liberalize, privatize, commercialize. So instead of the main backbones run by the National Science Foundation, commercial internet exchanges were set up. And there was the formal institutionalization of internet governance bodies, such as the Internet Architecture Board, the Internet Engineering Task Force, and the Internet Society. So there was the debate, are we going to use the OSI protocols or the OSI model? And this led to a huge resistance within the Internet Engineering Task Force. There was a strong resistance against their own US government, Japanese and French and other governments that came together in the ITU and in ISO to support their standards model. And why they rejected it so much was because they did not want governmental control over the networks. Because they experienced that before with the telecommunication networks, where they could not develop and roll out their own protocols. So this process nearly led to the Internet Engineering Task Force removing its own governance body, the Internet Architecture Board, by stating we are not going to comply with the OSI model, and we are not going to have states that say what we can do on the network. So in this period, some very important mottos came up. First, my network, my rules, and at the end of this meeting, the conflict between the Internet Architecture Board and the Internet Engineering Task Force was subsided in the presentation by Dave Clark, where the later unofficial motto for the IETF was coined: we reject kings, presidents, and voting. We believe in rough consensus and running code. So here engineers were setting up their own governance system for the internet, where they did not want voting, but did so through rough consensus. And they determine rough consensus in an interesting way. They do so through humming. So if you understand what humming is, please hum now. Exactly. So this is how conflicts and decisions about internet protocols that rule the internet are actually made, which is fascinating, right? And so while the OSI model is still being taught, it was never implemented. And that's why OSI was a beautiful dream, but TCP/IP was actually deploying the model because it had running code. And that, but one idea that's from the OSI model stuck, and that was the layering, the different layers that were introduced. And the governance over the different layers resulted in a distributed governance landscape in a wide number of different bodies, such as the Internet Engineering Task Force, the IEEE, the 3GPP. And that is why we have so many different bodies at the moment, where I mostly look at the logical layer of the internet that connects all the different cables and networks that exist. Because the internet, as internetworking says by itself, is actually a network of loosely connected networks that are able to interoperate through these protocols and through this voluntary governance. And I argue that in this distributed governance landscape that seems hard to allow for capture, control is exercised through infrastructural norms, which are a kind of infrastructural power. And in political science, we understand infrastructural power normally as the power of a state to rule over its territory by disseminating through its society. But it's trying to understand and apply this to the internet is a bit hard, because territoriality is, of course, works very differently in networks. And that's why I introduced the concept of infrastructural normativity. So through the setting of norms, control is exercised beyond borders, and it's a very effective way to shape behavior in a normative environment. And this allows the US government to actually take a back seat and still have a lot of influence by promoting this kind of governance over the world through this kind of infrastructure. Now, I'll try to look and see if I could find these values in the Internet Engineering Task Force. And the organization itself says actually it has very specific values. It even says that the internet isn't value neutral, and neither is the IETF. We want the internet to be useful for communities that share the commitment to openness and fairness. We embrace technical concepts such as decentralized control, edge user empowerment, and sharing of resources. not because that's determined by the technology, but that's what we think we should do. Which is quite a weird statement from a body that is filled with transnational corporations, isn't it? It's definitely not something what I expected. But I kept on coming back to three norms, three anchors for a socio-technical imaginary of the internet, which are the end-to-end principle, permissionless innovation, and openness. So the end-to-end principle actually stitched all the networks together by making the principle that the network should be dumb. And the only thing that the network should be doing is the transport of packets. So the goal is connectivity, the tool is the internet protocol, and intelligence is end-to-end rather than hidden in the network. This means that these translations that the router should make should not be made. It should be made in one giant data plane on which the end nodes actually could deploy their own things and could run their own applications and send their own messages. This also said that these end nodes all were equal. All computers that were connected to the internet should have the same possibilities. So this end-to-end principle has quite some constructive ambiguity between technical and political interpretations of these engineering concepts. So the second concept is permissionless innovation, which describes that while over this dumb network, you should be able to deploy any new protocol, and you should not need to ask permission to develop or design a new protocol. This was in part a response to the telecommunications era before, where the telecommunications providers said what you could and could not do on their networks, but perhaps also to the NSF net that had the acceptable use policy that you could not deploy commercial traffic. So they really wanted to be able to deploy any protocol or application that they wanted. And the third one, is also an interesting one, is openness. And openness is the ability for the network to keep on growing, to keep on adding new nodes. But it also has a conception of open standards, that if you want to define these voluntary standards, they should be freely accessible, and the governance of the internet should be transparent and open, and all decisions and discussions should be archived. So it sounds all pretty progressive, right? So the first big task after then not going with OSI and after the commercialization and privatization was the realization at a meeting in Japan, where a German statistician stood up. Somehow statisticians are often Germans, and he said, within 4 years, all IP addresses on the internet are going to be given away, and then we cannot add new devices to the network. So of course this was a breach of the concept of openness, and a solution needed to be made. So, and there were also issues of security, and people wanted to make more money of the network. So this led to a short-term solution of network address translation, where routers in the middle of the network were getting a public IP address, whereas the computers that were behind it were actually getting non-public facing IP addresses. This led to the production of inequality in the network. So the first real decision after the engineering community was cut loose on the oversight of the US government, inequality was introduced in the network by the production of users. Because the people that were behind the net did not have a public IP address, so they could not serve the traffic, the websites, or advertise the services that they wanted, because net directionality was introduced. So the computers could request stuff from the internet, but they could actually not serve as a server themselves. So these NOT boxes did not only create users, but also started shaping the traffic and adding what is possible and impossible. Under the guise of security, the NOT routers became gatekeepers. So they did not add functionality at the network, at the edges of the network, but in the middle. And so these invisible barriers led to something that's called ossification. Because when they tried to detect traffic, what is possible and what is not possible, they tried to understand what are existing patterns. And they could not anticipate for what future traffic was possible. So that led to a dependency on the world that already existed and an impossibility to anticipate on what would come. And this is illustrated by the deployment of a new version of transport layer security, where we tried to deploy TLS 1.3, and it worked perfect in the lab, but we failed over and over on the network. And we could not understand why. Until we started replacing the 3 with a 2. So the routers were expecting to see TLS 1.2 because that's what they've been made to up to that time. And they did not anticipate that the TLS 1.3 to be developed. So now the protocol, in its current way, is lying what it is. It's lying to the router. So in order to be able to design for the future, it needs to look like the past. And that we were able to do this trick with TLS 1.3 that looked like TLS 1.2 was still a bit of a success story. But the stream control transmission protocol that was developed as a replacement for TCP, which is a standard transport protocol, completely failed. People worked 15 years on this protocol, and it is deployed in all telecommunications routers, but it never worked on the internet because middle boxes simply were not expecting it and were dropping all the traffic. So this, of course, led to a lot of frustration and contention because the network was simply to be there to carry on packets, and that was exactly not what it was doing. So until something started to move, which was a protocol that is called QUIC, which has very similar ideas to SCTP about allowing different streams in parallel. And it also integrated encryption. But what was the big difference between TCP, between QUIC and SCTP? Is that SCTP was developed by Google. And Google had access to all their servers all around the world and the largest browser in the world, Chrome. So it could do A/B testing between their server and their browsers to see how it would work in the wild on the network where all different kinds of middle boxes are deployed. So this was not a case of engineering, but trial and error. And you could only do this much trial and error if you had this big presence in the network. And you'd say that it adds encryption, which is a nice thing. So, how many of you know how TCP works? Okay, great. I'll not speak to that part of the room. So the thing with TCP is it's a very reliable protocol in that it always establishes a session. So what it does, it says, hi Svetlana. Then Svetlana says hi back, and then say, okay, I'm going to send you something now. So these 3 steps in TCP are called SYN, SYN-ACK, and ACK. So, but this also means that every time you want to say something, you need to go through these 3 steps. And if you then also want to add security on top, so then you also need to negotiate the encryption protocol. You see that there are a lot of steps, and it's very hard then to send a lot of fast traffic. So what QUIC did is that it did not wait until Svetlana said, it's okay for me to start sending. I'm just going to send it to you whether you want it or not. If you don't want it, just keep the door closed. It's fine. And actually, that worked much better on the network, and it also assumed a standard encryption protocol, so it could do the negotiation later if needed, or it would be accepted. So it just assumed a lot of things. So this would then be a good thing, right? Because it's more secure and it's faster. Well, the fun thing is that it overcame indeed a part of the ossification of the middle boxes. But what it did is that it added encryption so that network operators could not drop packets or identify them. But it also strengthened Google as the strongest endpoint. Because what did it not do? It did not overcome not directionality. Because it is not in any means of interest of the largest content provider in the world that you start serving your own content. So here you see that there is a struggle between network operators who want control over the network vis-a-vis content providers that want direct access and want a stupid network, and how it's actually continuously being shaped. And what is also an interesting side effect is that with ubiquitous encryption, we can do far less analysis of what is happening on the network. So we actually do not know what Google, which is main user of Quick, is serving you. So analysis of the network, when it was not encrypted, taught us about the use of cookies on websites. And that led to privacy regulation. So how can we do proper research on an encrypted network? So even though encryption is a very important thing for privacy and in many cases for freedom of expression, it can also consolidate power relations of large companies. So in the battle between network operators and content providers, the equality of the hosts and the ability to deploy new protocols because has been subverted because of the ossification in the network. And so they have not been able to keep up with their own values of end-to-end and permissionless innovation when openness became an issue. So these were just their own values that they set, right? But what does this mean for other principles that we think are important on the network, if they cannot even hold up to their own progressive socio-technical imaginary? So this is the question that I wanted to ask myself when I started to look into the routing of the internet. And the routing on the internet happens between autonomous systems. So the internet is this network of networks that are often internet service providers or universities, and they have blocks of IP addresses, and every device on the network has a number, and because a range of numbers is dedicated to a specific autonomous system, which has an autonomous system number, it is able to route over the network. And here you see that the internet is like a complex map of all these different networks with different numbers that have then a set of subnets of numbers underneath it, of which you do not notice anything as a user of the internet. And there has been discussions about whether users should be able to decide how they could route over the internet, because different stakeholders have different interests, right? But here that principle of end-to-end was said to overcome that issue because the network is just going to be stupid, it's just going to transport packets. Well, this routing over the internet is actually a pretty hairy case because all the decisions are actually made based on economics. So not necessarily on what is the shortest route or the best way to route it or the most efficient way, but which networks exchange money with each other for what costs. So I try to design an experiment in which I could try to foreground the values in the networks. So I went to this governance institution and I tried to see if there could be a value framework that they could live with. So I looked for a value framework that was relevant, applicable, existing. I did not want to come up with something new. And that's transnational, such as the internet. So I took the General Data Protection Regulation, which is the EU law on data protection and privacy, and which is becoming one of the data protection standards around the world. And the interesting thing is that it's applicable for inhabitants of the EU and EU citizens, also if they live abroad. So a lot of networks should be able to respect this. The second principle I took was the second value set I took was the United Nations Guiding Principle on Business and Human Rights. So these are the consequence of the process of the codification and the application of human rights for non-state actors. So as you all know, the Universal Declaration of Human Rights was codified into different covenants, and then in the early 2000s, we started to develop guidelines for businesses to keep up. And this works really well or relatively well, in the garment sector, in the banking sector, but in the internet, which prides itself for being a very fast-moving, very progressive industry, respect for human rights gets very little attention. So I thought these are two value frameworks that are known that I could apply. So I proposed to add two pieces of code to the routing database. And it would simply say that this network is respecting the GDPR, or this network is respecting human rights. And then I could simply route my packets only over networks that respect my privacy or that respect human rights. So that's a pretty good idea, right? So, and because many of these networks are already in the European Union, they should actually already be compliant with the GDPR anyhow. Unfortunately, straight out of the door, my proposal got rejected. So the question was, why? That was because there is a very strong norm of interconnection that flows from this concept of openness, that the people working on the internet are trying to do things that are for the good of the internet. And the good of the internet is creating more interconnection. So it is a network ethic or a network market that you also see in social networks. The bigger the network, the more value for the independent parts. So anything that would actually hamper interconnection, such as laws, borders, but even security, are actually being rejected. And this was not just with the case with my proposals, but actually this was the case with also with Schengen routing, when the governments in Europe try to only keep data within Europe after the NSA scandal. India has also proposed this twice, and the engineers have only responded with, that's simply not how the internet works. So interestingly enough, they are also not deploying specific security measures for routing, because that could also lead to less routing. So it is this concept of more routing is needed, more interconnection is necessary, and that is the only guiding norm in this body. And therefore it's resisting a lot of other norms. So we've seen how in the Internet Engineering Task Force, some of their own values they weren't able to uphold. We've seen how in internet routing, how other values are actually being resisted. And now we go through one last part, because I think I'm also almost through my time-ish, which is 5G, which is the next generation of technology that is now going to wash all over us. And 5G is actually not a technology, it is a marketing concept. And it is an extremely successful marketing concept. Because the 5G standard, which is actually a combination of 23 different standards, haven't been fully finalized yet. But a lot of governments have already signed on the dotted line to be the first to implement 5G. Actually, many governments have funded companies to be the first one to implement in their country. And what is happening with 5G is that we're actually going back to the future, because a whole new infrastructure is needed, because another frequency is being used for the deployment of the network. A lot of new antennas need to be built. And there are only a few companies that can do this. And these are the large telecommunication providers. And these telecommunication providers are developing this technology in the 3GPP, and together they will have access to most of the routing traffic. So where we had all of the different network of networks, we see now a consolidation in a few telecom operators who are also developing new technologies on all different parts of the stack. Because when you hear 5G, you think it's just simply going to be a better version of 2G, because 3G was better than 2G, 4G was better than 3G, so 5G is going to be better than what's before, and it's going to be similar, right? No, it's going to be something completely different, and it's also going to replace, arguably, and that's what they say, parts of the networking stack and part of the different parts of the radio. So this means that the internet, as we know it, is actually now partially being taken over by these large consolidated telecom providers. So we almost return to a pre-internet age, but through means of modern computing, because what's happening now is that where we used to have all these routers that did a lot of translation and the NOTs that were in the network, these were all reliant on dedicated hardware. They could perform one function. And that was because memory was relatively slow and relatively expensive. But with the price of memory going down and getting much faster, the networks in 5G are actually set as through paradigms of software-defined networking. So the network becomes a huge data plane that is not actually layered, but can be completely configured. And the radio as well also doesn't work as a giant field, but actually as a direct aim at your device. So the network is going to be completely computable, adaptable, and configurable by these large companies to serve you with exactly what you need without you having the possibility to understand what is happening. So, what I try to convey is that network topologies can be very different, and they can have very different consequences for the values that they have and for what you can do on them. More interconnection and the end-to-end principle or an intelligent network does not need to be the norm. And ever finer grain control is not a necessary function of computing. So while we integrating networks and devices further and further in our life and how they wire our societies, we can design and reimagine them. And that is the hopeful part of this story, because as we've seen in the presentation, the network is being reinvented and is evolving. So we can also influence that. And we can do so with new visions of concrete technology. We can do so with new visions of governance, of law, of institutions, and of identities. So right now, the network is shaped between the interests of network operators and content providers, and soon largely by the network providers that are the telecom operators. So the network operators get, of course, aided by equipment providers and state, but where is the user in this? So where is the user that was actually a producer when all the nodes on the internet were equal? Because right now, that producer just became a user and a passive data subject. So looking at the data streams, we see what kind of network we're getting and what the network is optimized for to do. But we can also imagine new networks. And the nice thing is, we can resist bigness. So we can experiment with setting up our own networks or our own layers. And scale and interoperation is actually a norm of control. So we can also set up our own networks in our own conditions in which we can negotiate on how we wish to communicate, instead of being part of a transnational control network. Thanks so much.